Hello students, welcome back to the sixth video of this playlist. In this video, we will discuss question number 15 from the most recent past paper of Physics Unit 2, which is the October 2024 Unit 2 paper. So let's get started with question number 15 of this paper. So here the question says a strain gauge is an electrical component that can be attached to an object to measure mechanical strain. The strain gauge shown has 6 metal strips attached to a small piece of insulating material. The metal strips are joined together by connectors. The initial length of each metal strip is 18 millimeter. So the length of each of the metal strips, it is 18 millimeter. So part A here, it says each metal strip has a rectangular cross section. It has rectangular cross section of width 1.40 millimeter and thickness 0.23 millimeter. Okay. The resistance between the terminals, it is 0.16 ohm. Okay. The resistance between the terminals. Where are the terminals? This is one terminal. This is another terminal. So between this terminal to that terminal, there are 6 strips, right? So basically this resistance, it is the total resistance for the 6 strips. So you should be aware of that. Okay, it's for the 6 strips. Fine. Okay, the connectors and terminals have negligible resistance. Determine the resistivity of the metal used to make the strips. Okay, the resistivity. Okay, the formula for resistivity, it is rho equals to R. This is the resistance times area of cross section of the conductor over the length of the conductor. Okay, so the length of the conductor, it is 6 times, since there are 6 metal strips, and length of each of the metal strips, it is 18 millimeter. So 6 times 18 times 10 inverse 3, that much meter. I have converted millimeter to meter by multiplying by 10 inverse 3. So that would give you 6 times 18, this is 108 times 10 inverse 3 meter. Okay, we got the length. Now the area of cross section of the metal strips. So area of cross section, the question says they have rectangular cross section, so width is 1.40, width times thickness. So 1.40 times 10 inverse 3, that much meter, times thickness. Area of rectangle, it is width times the thickness, which is thickness is 0.23 times 10 inverse 3, that much meter squared. Okay, now just calculate the value. 1.40 times 0.23, so that would give you 0.322 times 10 inverse 6, that much meter squared. Okay, so we need the resistivity. Rho equals to resistance. The resistance between the terminals, it is given as 0.16. So 0.16 R A. A is 0.322 times 10 inverse 6, that much meter squared, over L. RA over L. L is 108 times 10 inverse 3, and the unit for resistivity, it is ohm meter. Okay, so what would be the resistivity here? 0.16 times 0.322 times 10 inverse 6 divide 108 times 10 inverse 3. So that would give you 4.77037. Okay, 4.77037 times 10 inverse 7, that much ohm meter. Okay, so up to 3 significant figures we can write 4.77 times 10 inverse 7 ohm meter. That's it. That's the answer for part A from question number 15. Fine. Okay, next is part B. In part B of question number 15, the question says the strain gauge is stretched and the length L of the metal strips increases. Okay, the length L of the metal strips increases. Okay, the metal strips change shape uniformly along their length. So the shape of the metal strips changes uniformly. Explain why a graph of the resistance of the strain gauge against L squared would be a straight line. The temperature of the metal strips is constant. Assume that the volume of each metal strip is also constant. Okay, L squared, uh, the resistance against L squared. Okay, so for that you have to relate the relationship between the resistance and the length of the strips. Okay, so we can relate uh, resistance with L squared using the formula of resistivity. We know that rho equals to RA over L, right? So from there, if you make R the subject, we know that R would be R equals to rho L over A, right? So if we multiply the top and bottom of the right hand side, so R equals to rho L squared over AL. So area of cross section times L, it is basically the volume, isn't it? So we can write here rho over V times L squared, right? So here temperature is constant, so rho is constant, right? Constant, and V is given as also constant, right? So if you take R on, like if you draw a graph of R to L squared, okay, so a graph of R to L squared will have a constant gradient, isn't it? Will have a constant gradient that is m equals to rho over v, which is a constant, isn't it? Hence a straight line. Hence a straight line, because a straight line has a constant gradient, isn't it? Straight line. That's it. That's the answer for part B from question number 15. Fine.